morning in Jena, two researchers in the fast lane. Jürgen Popp and Ute Neugebauer are working on a development that will revolutionize the healthcare system, an effective instrument for use in the battle against bacterial infections. I'm especially proud that we've been able to combine a medical issue with spectroscopic techniques. The background? The excessive use of antibiotics has led to growing resistance. More and more treatments are no longer effective. Pressed for time, doctors often prescribe antibiotics before the pathogen and resistance have even been identified. This is because the standard diagnostic procedures are elaborate and time-consuming. A very promising new method has now been developed.
This is our latest antibiotic chip. Of course, we hope that this will allow us to revolutionize antibiotic resistance testing. This chip makes it possible for us to add bacteria directly from the urine sample, select the different antibiotics we want to test, and then identify the bacteria that were the cause of the infection. And at the same time, the antibiotics the strain is resistant to. And all this happens in just a short amount of time. The entire procedure takes just 3.5 hours.
The laser-based RamanBioAssay makes it possible to help patients targeted and faster. To achieve this, the researchers in Jena have combined classic microscopy with biophotonic methods. I place this under the microscope, switch on an electromagnetic field. The bacteria, which are scattered in small amounts throughout the sample, are rounded up until they are all gathered at the center. Then we can expose them to the laser beam, collect the backscattered light, and analyze it using statistical procedures. After 3.5 hours at the very latest, we know whether the bacteria are sensitive or resistant to the selected antibiotic. A molecular fingerprint of the pathogen appears. Using this information, both the pathogen and the resistance pattern can be identified in less than 4 hours.
The conventional procedure involves sending a biosample to clinical microbiology where the sample is placed in a culture medium. Then you usually have to wait for 24 hours. This is a very long process, which makes it impossible to begin treatment immediately or to choose the fitting antibiotic treatment.
Dr. Bauer, chief physician at the University Hospital, is well aware of doctors' daily race against time.
This is a potentially life-saving development for the individual patient, but also for the healthcare system, and could get us out of the bind we're in because of the growing resistance.
The unique chips are made at the Leibniz Institute for Photonic Technology. In the near future, it will be possible to perform several analyses at the same time on a small diagnostic unit. A Raman to go, so to speak.
What we see here is the next generation of chips. We can analyze 3 samples on these chips, 1 control and 2 antibiotics of choice, either the same or in different concentrations. This chip has been designed for use with a mobile device.
They've been an unbeatable team for 15 years. Jürgen Popp was Ute Neugebauer's doctoral advisor. Today, they're learning from each other. Jürgen is focused.
Ute is ambitious.
Jürgen is dedicated and a visionary.
What I definitely am as well is very spontaneous. There are times when nothing is going fast enough for me.
Preferably by today, and if you need more time, then by tomorrow.
And this is what drives people up the wall occasionally. Cheers.
Cheers. For Ute Neugebauer, a mother of 2 small children, it's not always easy to juggle family and career. But her research is near and dear to her heart. The topic we're working on also deeply interests me personally, and I'm very happy that there is a medical need for it. It keeps us working on understanding why bacteria make us sick, why they develop resistance. Therefore, the subject is one we are very curious about and interested in.
Also große Neugier und Interesse an dem Thema.
The things in which we have now reached a certain level scientifically, that we will still be able to take the next steps that will allow us to provide both patients and doctors with new methods for diagnostics and treatment.
And the lab-on-a-chip system will soon be able to fit into even the smallest handbag.
Here we see the first version of a more or less portable Raman device. The next generation is no larger than a coffee maker, but ultimately able to do everything that we need to have done. This device, this technology is already being used in hospitals today.
It'll be even smaller, more compact, and fully portable in the future. You'll be able to use it everywhere, even in places where there's little infrastructure.
And that is our grand future.